Baik, kerajaan akan memperkenalkan program pertanian bersasar di bandar sebagai ajakan kepada pengeluaran hasil pertanian negara. Dan Perdana Menteri Datuk Seri Anwar Ibrahim berkata, kejayaan program pertanian bandar di negara jiran Singapura wajar diteroka serta dicontohi di kawasan kekurangan tanah di bandar dan juga di pinggir bandar dengan permulaan di Kuala Lumpur.
Okay, from the previous video, I mentioned and our government mentioned that we need to do agriculture in town. So that our main problem that we need to solve. So our problem statement for this project is urban resident, especially those living at condo or apartment, have limited or no space for gardening, making it difficult to grow their own vegetables.
Hello to our panel and viewers. This is our IDP project named Smart Fertigation Monitor System, or we call it SMARTAgra.
Project summary. SMARTAgra is a smart agriculture system designed for urban residents with limited space for gardening. It uses IOT sensors such as pH, EC, and soil moisture to monitor soil conditions in real time. The system provides recommendations for irrigation, fertilization, and suitable crops through a mobile app, along with alerts on plant conditions. This helps users grow vegetables and helps more efficiently, improving productivity while supporting sustainable urban farming. Objective of SMARTAgra: to develop an IoT-based smart agriculture system that monitors soil conditions in real time using pH, EC, and soil moisture sensors. To provide users with recommendations for irrigation, fertilization, and suitable crop selection through our mobile applications. To improve the efficiency and productivity of urban farming by delivering timely alerts and supporting sustainable gardening practice in limited space. Scope of work. For hardware and mechanical design, we built a mobile hydroponic rack with real-time water circulations. The system also uses pump system to mix nutrients and recycle water through filtrations. This part focuses on the physical structure and water system of hydroponic setup. For electronic system and sensor, we use pH, EC, and moisture sensors for real-time monitoring. A microcontroller processes data and controls pump based on system conditions. For IoT and user interface, we developed a mobile app allow remote monitoring through Wi-Fi. An LCD screen provides real-time local system status.
So now in the methodology part, I'm going to talk about the flowchart of this project and this device. So first, when we turn on the system, it will welcome us with the product name, which is SMARTAgra, and then it will start to connect to Blink. Also, the LCD will be turned on. So after some time, it will connect to the internet, and it will connect to Blink, and it will display all the sensors values, which is the first moisture sensor, the second moisture sensor, the pH sensor, and there's an analog TDS sensor which measures the EC sensor. And then the sensor value will also be sent to the Blink app, which has a Blink dashboard. And then the user can turn on and off the water motor pump, which is located at the bottom, which uses a relay also. And the system will be repeat.
Hello, my name is Haziq. Today, I will present about our IDP project prototype. As you can see, this is how our IDP project look like. Okay, first I will explain the height. We take 3.5 feet, and then the length we take 3.5 feet also, and then the width we take 2.5 feet. Okay, as you can see, we use two train pin, and we measure it. We take 3.5 feet or so. Then we have two tank on the top and at the bottom. Both of the tank take 10 liter, and we got one motor under here. It actually 0.6 horsepower.
So now I'm going to talk about how our project sensors work. So in this tank, there is two sensors, which is the pH sensor and the analog TDS sensor which measures the EC value, which is right now there is fertilizer in there, so our EC is 0.5 above average and our pH is 7. And the moisture sensor is, since the water is turned off, so the moisture is less. The moisture one is at this trunking, which is at the end of the plant, and the second moisture is at this trunking, which is at the dry end of the trunking. So now I'm going to show you our blink, which also has the same value as the LCD display. Also can control the water motor. So now I'm going to turn on the water motor. As you can see, it turns on and it transfers the water to the top of the tank, and the water will flow down. So now, as you can see, the moisture level for the trunking first is increasing, which proves that our sensor actually works. And the second moisture sensor is at the dry end of the trunking.
Okay, so now I will talk about how our project works. Okay, first of all, I need to pour our fertilizer. This is our A fertilizer and this is B fertilizer. We need to combine its both. We need to stir it. Okay, we need to stir it. Okay, and then after we stir it about 3 or 4 times, we need to turn it. Okay, Uma, please turn it. Okay, I will show you how it works. Okay, first of all, after Uma turn it, Uma turn from the phone. Okay, we need to open our stopcock. This is our stopcock, and as you can see, come here, our water will flow in here and in here. Okay, in here. After the water flow come, it will end up to here and here. After the water fill the tank at the bottom, the water pump will full the tank at the above. Okay, so we do it about 10 or 12 cycle to make sure our beloved plant get enough water and enough fertilizer. So as you can see, this project and this product is successful because you look at here, we have our beloved plant. We plant sawi pak choy.
So for this IDP project, we have a budget of 350 ringgit. So we only use budget-friendly sensors and microcontrollers such as ESP32 and normal pH and analog TDS sensor. So for future improvements, we have some suggestions. Some of them is switching to Raspberry Pi, which gives us more efficiency, more power, more speed. And then we can also, another improvement is we can also use more accurate pH sensor and more accurate EC value, which can read the EC value and the pH value more accurately. And then another improvement that can be made is adding a solenoid valve, which is an electronic valve that can be controlled using blink. So that means we don't need to be at this project to even turn on the water supply, water flow. So that means we can only just turn on from our phone the solenoid valve and the water pump, and the project is already running. Okay, so thank you.
For discussion, our project can measure EC value and pH value. From there, we can know how much the amount of fertilizer that we need to put inside the tank for the plant. It will make pH and EC value stable. Okay, it actually make the hydroponic work more simple.
So, for our panel and for our listener and viewer, I want to conclude that our problem statement is solved. That our problem is people at condo and apartment and terrace house. It's difficult to do agriculture because the place is very small and there no land to plant the tree. So as you can see here, our project is hydroponic, but it scaled down and make it easier and make it simple to we do at our home and our condo. So our problem statement is solved, and yeah, our project is successfully done. Thank you.